All right, it is the top of the hour, and we'll go ahead and get this thing started here in just about 30 seconds. All right, well, thank you everybody for dedicating some time to join this webinar today, Make the World See with AI Bridge for Developers. My name is McConneha. I'm a Community Relationship Manager here at Milestone Systems. I help our technology partners navigate the Milestone ecosystem and help our sales team lead with those partner solutions. I recognize some of you may not know what Milestone XProtect is, so I'm going to take just a few moments before we get started on this AI Bridge webinar to highlight what XProtect is and why, how it fits into this conversation. Milestone XProtect is at the center of all of an organization's technology, bringing in components, things like cameras, sensors, servers and storage, networks, encoders, video analytics, and access control. We do all of this to help keep people and property safe. And beyond that, Milestone also helps with beyond security solutions like traffic studies, retail stocking of goods, and an example of a real world AI bridge solution is Milestone's Hospital Assist, where we can monitor for hospital patients that have fallen out of a bed. Immediate recognition of these events help mitigate additional risk or injury to patients. With 14,000 plus devices supported and over 500,000 installations worldwide, Milestone is leading innovation with 3 annual releases every single year. And with 20 years in market experience, we're proven it's the right answer for those installations. Anything from florists and universities to stadiums and cities, Milestone is at the forefront of VMS. We are the open platform. Milestone XProtect's architecture has fostered an ever-expanding community of camera manufacturers, application providers, and you, the software developers, all working towards creating integrations and extensions to XProtect. By leveraging you, the community, and thousands of integrated solutions, our end users add additional value and capabilities to their XProtect systems. Milestone's integration platform historically has utilized MIP SDK, MIP VMS APIs, and driver frameworks to bring in devices to the Milestone platform. And today, we're going to be talking about a newer technology called AI Bridge that helps you bring in your technologies and the value of those integrations to Milestone. With that, I'm going to hand it off to Hans Kierulff. Let me see, I'm sorry. Hans, go ahead and take it away.
Thanks, Art. Yeah, my name is Hans Kierulff, and I'm product manager for the Milestone integration platform, and that includes the AI Bridge. At the same time, I'm also a developer advocate, so I help developers like yourself on with getting the solutions right and making architecture designs and stuff like that. So let's see here. So what is the AI Bridge? Coming here. Yeah, so the Milestone AI Bridge is an API gateway that eases the integration of intelligent video analytics applications with XProtect. Those video analytics applications are going to be developed by you, our technology partners, and developers around. So the AI Bridge provides access to video streams for all the cameras managed by XProtect and enables sending events, metadata, and video back to XProtect, the XProtect video management software. And you can see these cameras can be, from installation for the florists with 10 cameras to the mall with 1,000 cameras or whatever setups, and you get all these video channels enabled through the VMS. So the AI Bridge itself is built with containerized microservices based on standard protocols, and those microservices are, by the way, Docker containers. So they are really good running in Kubernetes environments and stuff like that. So a little bit closer look here. So the AI Bridge is enabling technology partners and other developers of intelligent video analytics applications. We call them IVA, right? Intelligent video analytics applications. And applications like that are utilizing Dockers and Kubernetes, and potentially leveraging NVIDIA's ecosystem, as we should hear more about today, to easily integrate their IVA applications with XProtect. So it's a bridge between the analytics world and XProtect, the VMS world. So a typical solution flow, data flow, could be that you read a video from the VMS from one of the selected cameras or many of the selected cameras, depending on what analytics you are developing. Read that video, typically we see using RTSP streams. And then you do your magic, you do your analytics, probably use NVIDIA frameworks to do that and GPUs and all that to do the analytics. And the result of those that analytics, you can send that back to XProtect as events that something is happening in the whatever video you recognize. Those events can trigger actions inside XProtect, for example, starting video recording or something else, and eventually also be populated as alarms for the guards or whatever, whoever is or nurses or whatever is attending the situation. So another way of posting back information from the analytics is using metadata, and that will typically be frame by frame information. So for each frame you get for analytics, you typically will identify objects and stuff like that, and that you can describe in a metadata document. You can post back to XProtect, and that metadata can then be used in XProtect for viewing in the viewing client, XProtect client, as bounding boxes around the objects, around your cars or persons or whatever it is. And you can also use it in XProtect search. So if you want to search for, let's say, the red car or the person with the blue hat or whatever it is, you can utilize the information in the metadata and search that, and then find the related video to see that. So that's a typical data flow. And just to show one example here, this screenshot here is from an alarm, and it is based from this patient fault detection, which is done using an algorithm, an AI-based algorithm. It views a patient room, and as it often unfortunately happens, patients somehow fall out of on the floor or out of the bed, and that is a very serious situation. So that will be detected by the algorithm that will then send back an event to XProtect, and which eventually will be raised an alarm and be shown here to the operator or to maybe the nurse or whatever, that then will go and look at the situation and can see the situation live here or recorded if it is recorded, and act upon it basically fast, right? So that's a typical use case, and you can see there's a small bounding box here of the fallen patient and so forth. So that was just an example. So again, a little bit slightly more detailed here with the combining the two worlds, the VMS world on the left side, managing maybe 2 cameras, maybe 200 or 2,000 cameras on the particular installation, cameras, microphones, switches, IoT equipment of all kinds of things that is managed by the video management software. And then in order to get connected to this to the video, could be recorded video, could be live video from these cameras, you in your application, the IVA application, you use the AI bridge. And typically you will start in the middle, querying for information from typically the cameras, which cameras are available, what stream quality do they have, frame rates and so on, and codecs and stuff. So you get back the URL, the RSTP URLs of where these cameras are, and that is seen from the VMS point of view. No matter the type or the brand of the camera connected to the VMS, you will always be able to get this RTSP feed out of AI bridge. So you feed that into your IVA application, do your magic, and then post back on what we call topics, so which could be the event topics, or the metadata topics, or even video topics, where you, if you generate, let's say, redacted video or something like that in the maybe face blurring or something like that in the application, and then you can feedback that video as well. And we support different protocols, RTSP and GraphQL for getting the configuration, and REST and gRPC and others to post, and Kafka to post back the results of the analytics. So what is the benefit? So the benefit is that we want to improve how you integrate your intelligent video analytics applications with Milestone XProtect VMS. That is the purpose of the AI Bridge, to make this integration easy for you as a developer, and of course also for deployment out there. Yeah, so benefits is this is based on a modern architecture. It is the well-known Docker technology, and the purpose here is to provide better insights about what is happening in the video, what is going on in the video, and better insights for the users of the systems. And we strive to do that by providing a modern API with modern protocols that are easy to use for you as a developer. So, and here we have a customer statement, and that is a developer statement who has previously used other ways of integrating with analytics from XProtect, and in his particular use case, that was hard to do. It was doable, but harder, and that's why we are developing and providing the AI Bridge to make this integration, getting the RTSP feed ready for analytics, and some easy to use APIs to send back the results. So thanks for that statement. So how can you get started if you are a developer and you want to work as a technology partner, or just using our AI Bridge? First of all, there will be a customer out there with an installation of XProtect and a number of cameras, and you want to provide them with some analytics capabilities. And that could be, you could use the general platform of APIs. Everything more or less can be accessed in XProtect. And then of course you can use the more dedicated AI APIs in the AI Bridge, and that you can host that and deploy that using NVIDIA EGX. So we do a lot of to make sure that we are compatible with the NVIDIA EGX stack, which you will hear more about, right? Yeah, so our containers, the Docker containers, are stored in the cloud on what is called NVIDIA GPU Cloud, NGC, and that's where you get them from. This repository for containers. So you will get in your resulting application, you will have access, you will get our containers for the AI Bridge. You will deploy probably also at the EGX and NGC your own analytics containers, and that will all run in the same cluster. And through that, accessing XProtect as described before, getting configuration, getting video, maybe posting back video, and also posting back metadata and events. So you have a customer with an XProtect installation, you have some infrastructure for production users, typical Kubernetes, could also be Docker Compose. Then you have, of course, what you're supplying here, that's the analytics, right? So to get started, we have a small folder or small description here where you can sign up to get access to the repository on NGC where the AI Bridge is stored. And on that repository, you will find a lot of documentation as well, and developer documentation and so forth. And I'm sure that our host will post a link to this document, or even the document itself, here in this environment. So with that, I give the word to Poonam from NVIDIA to tell more about all the features you supply. Thanks.
Hi, thanks Art. Thanks Hans. So my name is Poonam. I manage our developer relations and ecosystems at NVIDIA, and I lead the Metropolis platform. So what I wanted to go over in this presentation, thank you again for joining. Sorry. So, speaking about NVIDIA, many of you have heard about NVIDIA, and we are really pioneering the accelerated computing platform. So what we like to do is we like to make challenging problems solvable our stack is not just hardware, but also a lot of acceleration libraries. And we bundle these acceleration libraries into what we call application frameworks. So, and here you see some of the application frameworks. Metropolis is one such framework. It is a framework for vision AI. So in the next 15 minutes or so, you have heard from Hans about the Milestone AI bridge, and you heard from Art about, you heard about the Milestone X Protect system. What I want to go over is I want to talk to you about how this platform with the AI bridge and with the power of NVIDIA's generative AI software is actually ready for the next wave of revolution that is coming our way in terms of, in the vision AI applications. And I'll speak to the vision language models, which is the latest model architectures that are coming in. So first, let's talk a little bit about Metropolis. Many of you are partners with, they are using Milestone. They're also using some of our ISV applications, and many of you are developing ISV applications, IVA applications for Vision AI. If I were to quote one of the pioneers of AI, pioneers of vision AI, she had said that, eyes is really, vision is really from eyes, but what happens is inside the brain. So we think about the vision AI problem as, the vision starts with cameras, but what is the brain is really the AI model, really the AI application that's running behind it. And so the NVIDIA Metropolis platform actually provides a lot of tools for you to jumpstart your AI development, starting from creation. So creation stands for the data generation, the data set generation, the gathering of the data. We all know that AI models are only going to be as good as the data that they are trained on. And so, once you have this data ready, then you can leverage some of the pre-trained foundation models that NVIDIA has. These are all from state-of-the-art architectures, and these models are available for you to develop and fine-tune to make them your own, or use them right outside the box. And the NVIDIA Tau toolkit, which is used for fine-tuning and customizing these models. So ready to use simple APIs and simple, the Tau toolkit itself is based on some of the frameworks like TensorFlow and PyTorch. And so here, what we are trying to do is help you start very quickly, help you get started for the development of AI models very quickly. And on the build side, there are tools, there are SDKs such as the NVIDIA DeepStream, which is a very popular SDK, which helps with video processing. It is built for video processing. So when you are ingesting the videos, if you wanted to compress them, if you wanted to accelerate them, that's where NVIDIA DeepStream comes into play. And lastly, there are NVIDIA microservices. So increasingly, we are building more and more microservices because we understand that sometimes the using of SDKs can, be complex, and maybe you don't have a lot of developers, AI developers in your organization. And so the microservices use standard APIs and very, very easy to use. They plug into API gateways such as the Milestone AI bridge and all the other applications that our other ecosystem partners provide. And all of these models, once you have developed them and built them and optimized them, they are ready to be deployed anywhere, on any device. So just want to go over briefly some of the latest visual foundation models from NVIDIA. So these visual foundation models are really transforming the landscape of computer vision. starting with the NV clip model. So, 2 years ago, actually, OpenAI came up with this, contrastive learning technique, which is the clip model. So this is a vision plus a text encoder. So essentially, what NVIDIA did was we took the architecture and then we trained the clip model from scratch using 700 million image and text pairs. So, this model training actually happens with image as well as text pairs. This is important because, these types of models that use multimodal, they use both image as well as text, are becoming very popular. They are becoming very popular in use in computer vision applications. And we'll see some of the benefits of these types of models going forward. There's also NV-Dino. So many of you are familiar with the Dino model, which is a vision encoder. And this vision encoder is, it's a very interesting take on the transformer architecture. So if you remember, about 2 years ago, almost 2 years ago, ChatGPT created a revolution, right? Because it created a revolution in terms of language. So the Dino model actually started to, it started with the idea of a transformer, how to use transformer for vision. And so NVIDIA, the NV-Dino V2 is actually an attempt of NVIDIA. And, we are training these models from scratch using the data sets that are prepared, properly sourced data, and they are commercializable. So one takeaway, if you can take away one thing from this slide, is that the models that are provided by NVIDIA, they are pre-trained on properly sourced data, and they are commercializable. So what this means is, sometimes you look at research models, you look at, the model architectures that are coming from academia, you will see that you may not use those models in commercial, applications. And so what NVIDIA is doing is we want to help our partners, get started fast building AI applications. So we have taken care to build these models from scratch, to pre-train them on data sets that are properly sourced, so that you can take this model and you can commercialize it, meaning you can build applications using these models, and then you can build services on top and provide them to your end users, to your customers. So again, grounding Dino is a popular model that's open vocabulary object detection model. So it takes the elements from the Dino model and it applies some vision capabilities to it. And then the mask grounding Dino is another model, which is open vocabulary segmentation. One really interesting model here that I'd like to point out is also Visual ChangeNet. And Visual ChangeNet is actually a very interesting model because it detects pixel level changes and it outputs the mask of the changes that we're seeing. And now once you have the output of this model, you can use another model like Grounding Dino, for example, to process it further and use it in your application. So all of these models are available, online. You can go to our, documentation and read more about them. So moving forward, we have the models, the foundation models, and maybe these models work really great for you out of the box. And in most cases, you actually want to customize this model. You want to customize it by fine-tuning it. And that's because you want to make that model your own, because your use cases, Hans gave an example of the hospital use case, for example. So you want to make that model run for the industry, for the use case that you are working on. And for that, a lot of times you would have to customize the model. There are several customization techniques like full fine-tuning, there is a last layer, or head fine-tuning, and there's also in-context learning fine-tuning. So all of these techniques are supported by the NVIDIA Tau toolkit, and so essentially you can use the APIs from the Tau toolkit to fine-tune any of the models that I mentioned before. So now, changing gears a bit, I wanted to talk about generative AI. So vision language models, or VLM for short, have really changed the game for video analytics applications. So before the advent of generative AI, you would have CNNs, you would have these convolutional neural networks that are used for predetermined use. So this model is going to detect fire, this model is going to detect people, for example. And so that was a little bit of a static interaction, and this was a model that is built for something that is predetermined. Well, after generative AI and all the new architectures that are coming up, what is happening is there is rich contextual and generalized scene understanding. These models are actually capable to be generalized, meaning they don't have to be trained specifically to detect one thing and one thing only. And what this has done is it has increased the speed of the development cycle, because now minimal tuning is needed. Most of these models are zero-shot learning anyway. And so what we see at NVIDIA is that VLMs are really taking off. And if you have, paid attention to what's happening in the industry, the vision language models are really, they are evolving at an astonishing pace. I mean, every few months, every few weeks even, we see a new architecture that is coming up for image and video, for long video understanding, for spatial understanding, character recognition, and so on. So to this day, there are 100+ vision language models that are coming up, and some of these are proprietary, some of these are open source, and we are taking the best of them to make them available on the NVIDIA side. Increasingly, you also see multilingual models, meaning that vision language model is both vision and language. And now language could be any other language, any language besides English. So we see a lot of multilingual capabilities coming up in these vision language models, and many of them are capable of zero-shot detection as well. Here I'm just showing you a sampling, just examples of these vision language models. So firstly, we have the NVIDIA VLA model. So this model is NVIDIA's own model. This architecture is based on what is known as McConneha, and the model size that is offered starts from 3 billion parameters all the way up to 40 billion parameters. And it is going to be available soon for downloading and training. It is available as a trial right now. It is really good at video and spatial understanding. And then the next one is the Phi 3.5 model, which is Microsoft's model. This is a small model, so good for small devices, 4.2 billion parameters. It's fast and efficient. And then of course, who can forget the GPT-4o, which is OpenAI's model. And OpenAI's model is proprietary, meaning that only APIs are available to be used, not the model itself, not the architecture itself. But so far we see that that is the biggest model, because it's more than 200 billion parameters, and it's a very, very flexible vision language model. So now you will ask me, what are the benefits of these vision language models? What can I do with this vision language model? And right out of the bat, I'll tell you that these vision language models are powerful to analyze video content and use natural language queries. And the idea is that you want to be building agents, you want to be building AI agents inside your applications that are capable of summarizing events, of carrying out interactive Q&A, or alerting you, like the patient is falling off the hospital bed, and every time that happens, alert me on my mobile phone or on the dashboard that the hospital maintains, as an example. So those are some of the benefits of vision language models. And on the next few slides, let me actually show you what NVIDIA is doing to make these models very, very easily consumable and deployable. So the NVIDIA NIM microservice, NIM stands for NVIDIA Inference Microservice. is a container. So it's a model inside a container. There's also a Helm chart, and it uses APIs that are very standard to use, and it can be hooked inside any application. So that is the biggest advantage of using a NIM versus using a model checkpoint. And we have a website which is set up for trials. So we have set up this website for trying out any of the vision language models that are out there. And this is just a sampling, just to show you, there is on the vision language model, you can see Florence, which is Florence 2, which is another small model, and then the Vila 1.5, which is NVIDIA's model. There is a video model coming up, Vila 1.5 for video, and there's going to be multiple that are going to be available. The idea of this trial site is to enable you to try out vision language models. You can try out to see which one works for you. It is available for trial for all developers, everywhere. And then the CV NIMs, the computer vision NIMs are also available on this site, and you will see the NV clip model that I mentioned. So the computer vision models, think about them as really like playing a part in that entire model chain of the IVA applications. So you're using vision language models, but you may also need these computer vision models to kind of accomplish the use case that you're trying to carry out. So moving forward, how do you build these AI agents? Well, the way you build these AI agents is with the help of microservices. So there is a microservice called VIA, and this microservice, I'm going to demonstrate to you how easy it is to connect with XProtect and then use the AI Bridge API gateway to actually summarize the content of a video. There are simple API calls. It is customizable to a broad range of use cases, and it is optimized for NVIDIA GPUs. So you will get more than 60 times faster summarization of the events that are happening, in that video. So that's the beauty of the VIA microservice. And underneath the covers, it is using a vision language model. It is actually using the vision language model VILA. So this diagram is showing an architecture, and it's just showing you an example where you will have your ISV application where you have a user interface somewhere, and then it is connected to the XProtect client. As the videos are coming in from XProtect, you can use AI Bridge to connect to the VIA microservice. And the VIA microservice, which includes the vision language models and the large language model NIMs, will actually create a video summary with timestamps for the application. And once you get the output, you can process this output, you can massage this output, or you can filter it, and then you can use the elements from XProtect as well as your own AI application to kind of create the sort of interface that your end users are looking for. Really kind of helping the world see through the AI Bridge, because this agent that you're building, and I'm calling this an agent, like you're essentially building a visual AI agent, leveraging all the technologies that are available to you. So this demo is a very quick demo showing you, how to get started. You download the AI Bridge, you configure it with your IV application, then you install the plugin, and then you start via microservice, and that's it. So let me see if I'm able to play the video. And here you see the Milestone XProtect client. And this is the stream that it is connected to, a video stream. You go to NGC to download the AI Bridge version 1.7.2. And then you kind of look at, make sure that you have downloaded the right one. You can even call this bridge something like, name it, because you might have multiple AI bridges in your configuration, in your environment. Then you set up like the URL, the username, password of who is going to be accessing this, and then the external IP and host name. So before getting started, make sure that all the containers are running. So here you will see that all the containers have been started from the AI bridge, and everything is running, everything is okay. So now go back to the the XProtect client to make sure that there is a green icon that says connected. So yeah, so here you see that the status of the AI bridge is connected, and obviously you provide the host name, the URL of where the AI bridge is running. And the nice thing about AI Bridge is it provides this very nice little tool that you can query and see the results. So if you wanted to test out very quickly, you can use this tool to test out, where is the stream running, and is everything in order, and then you can get started. And then once you see that the RTSP that the stream is running, you download and start the VIA container, the Visual Insight Agent microservice. And here you can customize the prompt. You can customize, what is it that you're looking for in this video. And then you can also do like a summarization prompt. So the key thing here to remember is that the agents that you're building will need a lot of help from human. There is a human in the loop element to it. So you want to make sure that all of these captions, all of these prompts are properly set up. And then once you get started, this is connected to the the stream that is running inside XProtect, and now you get the summary of response. You get whatever it is that you're looking for in that particular video. And then this output, you can send it anywhere you like. This output, you send it to XProtect, and from there you can massage it to use wherever you like. So I hope that was useful, and I hope you are excited to start using or start trying out the Milestone AI Bridge with some of the tools that I mentioned from NVIDIA. I want to switch over to developer success stories, and I'm going to hand over to David Jenkins from IronYun, one of our ISV ecosystem partner.
Thank you, Poonam. Yeah, I'm with IronYun. We do video analytics. And what I'm going to talk about is an application we've done for traffic management and traffic incidents, alarms, where we're pointing cameras at traffic intersections and looking for various things. So the first thing I'll just to summarize the things we do, we retrieve a camera list. We have over 100 cameras. Our servers are running up in Amazon Web Service, but XProtect is on the customer premise. So we're running the streams up to AWS. So we retrieve a camera list. This is just, I'll go into detail on these things. Then we get the RTSP streams and retrieve them and process, run them through our analytics. Another thing we can do if the customer wants to replay recorded streams, historic, they can upload those and run analytics as if they came from live cameras. And finally, we send alarm triggers down to XProtect. And the nice thing, AI Bridge, we can use it from Python, Java, pretty much any language. So next slide. So let's talk about in detail. So first thing we do is we retrieve a camera list. And of course, here's an example on the right-hand side. It's got all the information, details about the cameras, the latitude, longitude, frame rate, what codec it is, H.264. And then if you look, we get RTSP URL and the video resolution. So all those things are useful to us running our analytics. So we'll set up this stream and then we'll start processing it. And we're bringing in cameras, various resolutions, various frames per second. And then we do our video analytics where we're doing object tracking for cars, buses, trucks, bicycles, pedestrians, all that kind of thing. And we're looking for different kinds of problems, intrusions where there's people in the roadway where they shouldn't be, car crashes, and just plain old counting objects, how many go through the intersection. We're also doing license plate recognition. And the nice thing with AI Bridge, it can be used in the cloud. As I said, we're running AWS, or can be used on premise, and it scales. Now, previously, we've used the Open Network Bridge. You may know it as OnVIF Bridge. Due to our bugs, we found out there's a limit of 1,000 connections and then it stops working. My understanding is that AI Bridge is scalable and servers can be just spun up to handle more and more streams. Now, another nice capability is replaying recorded streams. Because we are a Linux platform, we couldn't retrieve video, recorded video, through anything but the mobile server API, because other APIs are for Windows. And now we can use the AI Bridge. We give it a start time, an end time, camera UUID, and the stream comes in H.264 or whatever format. And then we run our analytics on the recorded footage. And then finally, the payoff, first, to send alerts to XProtect, first thing you have to do is register event topics, and those are the types of alerts you want to send. And then you send these alerts to AI Bridge to an event topic endpoint, and then that will be forwarded into Milestone XProtect, and things like license plate, recognize a license plate on your alert list, wrong way drivers, stalled vehicles, pedestrian in the roadway, different types of things we detect with our analytics. And along with the alert going into XProtect, we can send in a base64 image and other fields, a hashtag. If it's a license plate, we'll send the plate number. Any other stuff we want to send, we can send there. Here's how you register the event topic with AI Bridge. So here's a stopped vehicle event. Gives you back an endpoint that you can use to create those events or alarms. And finally, when you want to send one, you send a message to that endpoint. You give it the source, which is the camera UUID, an image, base64, any involved objects like the license plate ABC123, and it's all pretty straightforward. So, thank you.
Thank you, David. Hi, everyone. This is Maulik. I hope you can hear me. So just a quick introduction. My name is Maulik. I lead the AI business unit for Lanner Electronics. If you don't know Lanner Electronics, we are the leading ODM OEM service provider and hardware manufacturer targeting on AI applications, network computing, telecommunication applications, and security applications. So here, what I'm going to walk you through is the reference architecture blueprint, that how the software component works with the hardware component, because processing server is a critical component when it comes to a complete reference architecture. Now, if you look at the IVA application, it demands performance, scalability, and robustness. Now, NVIDIA has solution from Jetson to L40S data center grade GPU for video AI inferencing. However, how you can leverage this GPU along with the software component, what Hans, Poonam, or David mentioned earlier. So what we have provided and proven is that this is an architecture which works. So Lanner has a scalable platform starting from a Jetson to a data center grade GPU or DPU platform, depending on your workload needs. Now, this processing server has a capability to host AI bridge on a single or a scale of server or cluster of server, along with the IronYun video analytics solution, depending on what analytics you want to target, either a license plate recognition or a fall detection or people counting, etc. So now you can leverage this processing server and host multiple containers or your application, whatever you want to targeting natively or cloud natively, depending on how you want to deploy your solution. Now, these servers can host application and can help to communicate with your video streams coming from your camera endpoints, and then your analytics application can communicate via Milestone AI bridge to VMS site where it has been exchanging a metadata, event, alerts, or video files. So that's how you can deploy a complete turnkey solution depending on your workload need. Now, we have spent a lot of resources, energy on pre-validation or pre-configuration this hardware with various software component. And typically, these systems are known as AI inference system, where you utilize this is servers or edge devices at the far edge deployment site, where you can basically utilize GPU resources to drive video inference. On the left-hand side of your screen, you can see various QR codes. You can scan those QR codes, and that would give you a little bit of understanding how this server work with the software component, either from Milestone, IronYun, or NVIDIA. And you can learn more about that. For example, with NVIDIA, this server are NVIDIA NGC ready or NVIDIA certified server for enterprise and edge. With IronYun, these servers are certified for that core and edge product line. Same thing with Milestone. These servers are pre-validated with Milestone AI Bridge. There's also the critical component to this AGI server, which are hardware building blocks. So this server has to support various hardware building blocks. For example, security. So you need to have a trust point management module pre-built into this hardware for your key management, along with the tamper detection. Connectivity. For example, if you're deploying this device at the edge, you need to have some sort of connectivity. Either it could be cellular connectivity or Wi-Fi connectivity, whatnot, as well as the scalability to support your throughput, the network throughput. Other than that, you need to have the manageability. For example, if you want to have the IPMI or remote manageability or hardware-based manageability support for this device to deploy your video analytics application. And same thing as a flexibility. You need to have certain sort of flexibility to scale up. For example, if you want to use one GPU module or n number of GPU modules. Same thing with the video acceleration card or transport module, etc. So this is basically a building blocks how the pre-validation and certification has been done, and how we all co-work together to get you started with faster time to market. Now, going to my last slide is we have come up with POCs, or we have come up with deployments, and based on deployment, this slide or this data can give you some sort of server sizing guide. For example, if you're working on a project where there is 100 camera channel support required for the video analytics, how you can do it. And we have spent a lot of resources to basically help you on, as I said, faster time to market, save your engineering hours on pre-validation configuration with the software and hardware components. So one of the benchmarking data here you can see is that we have built a POC server, or we have deployed at customer premises one of the small edge device with NVIDIA A2 GPU, i7 processor, and 32 gig memory, along with IronYun core, as well as analytics microservice along with Milestone. And we have seen this performance out of this small device, which can support up to 24 channel. It could support up to 24 video search, object detection. It could support 24 instances of intrusion detection. Also, same thing with the license plate recognition. It can support up to 24 video channels and 8 video channels for object tracking. So this is more like a hardware t-shirt sizing guideline for you for the scalability of the project. Let's say if you're working on 1,000 project as you, 1,000 camera channel project, as David mentioned, this will give you some guideline. If you want to learn more, feel free to scan those codes. You'll get some sizing guideline over there. So that's it from our side. I'll hand it over to Art to open up a Q&A.
Thank you so much for that, Maulik. And yeah, let's jump right into the Q&A. I really thank all the panelists for dedicating time to setting up their presentations today. We do have a couple of questions in the chat, and I want to cover some of those now. The first question, if we can go ahead and unmute all the panelists, please. This question is going to be provided to Hans, if possible. Will the AI bridge be made available to run on-prem and support use cases such as on-prem AI appliances?
Absolutely. It is kind of designed to run where the VMS is running, which is typically on-prem. But it can also, as I think David mentioned, it can also be run kind of in the cloud away from the VMS, but it can definitely also be run on-prem. You need a Kubernetes cluster on-premise to run it, but yes, absolutely.
Yeah, and if I'm not mistaken, David, with IronYun, you had indicated that this is actually part of your solution today, if I'm not mistaken. Is that correct?
That's right. And the nice thing in the cloud, if you grow, you just spin up more servers and AI bridges scales as large as you want, and that's nice.
Perfect. Thank you for sharing that. I have another question I'm going to send to Hans. What data formats can I use to send metadata back to XProtect VMS?
Yeah, we support two formats out of the box. And the one is the NVIDIA DeepStream Minimal, which is used by partners that are already using NVIDIA's toolkits and producing this format. Then it's a very easy adaptation. Kind of for the more richer metadata description, we use the ONVIF metadata format, which is also evolving these years, and our support for it is also evolving. And we are now also participating in the ONVIF standardization work going forward. So NVIDIA DeepStream Minimal and ONVIF metadata formats. Yeah.
Perfect. Thank you for that response. I have another question
and
here.
You're muted.
I have another question here. If a camera outputs multiple streams, can AI Bridge provide access to either or both streams?
Art, you are muted.
Sure, I can take that one. Yeah, when you receive the camera list, it will provide all the streams for any particular camera, and then you can pick and choose from those. And if your analytic only needs to run at a lower frame rate, 4 frames per second, you're probably better off going with a stream that provides that, so you don't end up decoding 30 frames per second and throwing away 26 of them. So you can do it either way, but yeah, you do get all the streams for every camera.
Perfect. And I have one more question. I don't know if I sound like Hans might have had some issues with his speaker, but I have one other question. Will the AI bridge be made available? I apologize. Do you expect BB metadata to be generated from every frame at the same frame rate of the video source? Hans, if you can hear, can you take that one? We might have had a technical glitch there. So I think that ends that concludes all of the questions that we had for today. We will follow up with that last question. Oh, we had another question pop into the chat. We'll see if we can get this one answered. I don't know if any of our panelists will be able to answer, but we'll do our best here. Will a license be required to use the AI bridge? Again, I don't know if we have, I think Hans may have had a technical difficulty there. So we may have to come back to that. Yeah, with that, I think we're going to go ahead and close out the call. Go ahead and continue to send in your questions. We'll send out an email at the conclusion of this event and make sure that everybody has the answers to all of the questions that are provided to us. And again, thank you so much. I really want to thank everybody in attendance today for taking time out of their day to participate, whether just absorbing this content, actively developing solutions in the future, and then also asking your questions. I think that's all very valuable. I also want to thank for anybody who may be watching this video after the fact in the recording. And more than anything, I want to thank our panelists today, NVIDIA, IronYun, and Lanner. Thank you so much for developing the slide decks and speaking to this group today. With that, I do want to also mention in the handout section of this webinar, there is an AI Bridge Getting Started guide. I urge you all to download that before you jump out of the call, but we'll try to make sure we include that in the follow-up email as well. With that, thank you again so much for your involvement today, and we look forward to seeing you all next time.
Thank you.
Thank you.
Thank you.